Hello, everyone. Let's continue our discussion. First of all, let's have a review of the effects of financial leverage. Just now we know, right? Financial leverage, yeah, is is almost the same thing as capital structure. So, yeah, in the other words, let's look at the effects of capital structure. Let's look at, what happens to its ROE when a firm increases its financial leverage. That means, when a firm uses more debt, then what is the effect on the ROE? I think you can you can remember the DuPont identity. In the DuPont identity, we have ROE. ROE, that is return on equity. ROE equals ROA times EM. That is equity multiplier. Equity multiplier is defined as total assets. Okay, total assets divided by total equity, right? Yeah. If a firm increases its use of debt, then its total equity would reduce. Assume the total assets does not change, does not change, then the equity multiplier would increases, right? So yeah, we know when leverage, when financial leverage, I use LEV to represent leverage. When leverage increases, then total equity would decrease, and then assuming total assets does not change, then equity multiplier would increases, right? Now let's go back to our the DuPont identity. ROE equals ROA times equity multiplier. That means if the firm's ROA, return on total assets, does not change, when financial leverage increases, then ROE would change. ROE would increase. That right? So even if ROA does not change, when a firm increases its use of debt, then equity multiplier would change, would increase. And accordingly, ROE, return on equity, would increase. So that means when ROE increases, that means for $1 investment in the equity, the shareholders would receive a higher return, right? So yeah, this is why we call the financial leverage. That's why we call the usage of debt as financial leverage. Financial leverage amplifies the variation in ROE. Okay, of course, here I use amplifies the variation. If the firm uses smaller debt, then in this case, total equity would increase. Right? In this case, total equity would increase. Okay, and then equity multiplier would decrease. And in this case, ROE would decrease. Okay, so leverage amplifies the variation in ROE. Now let's look at the effect of financial leverage on its tax liabilities. Okay, when a firm increases its financial leverage, When a firm increases its financial leverage, its tax liability would reduce. Yeah, would reduce because we know. Yeah, because we know the interest expense is tax deductible. Is tax deductible. Okay, then in this case, tax liability would be reduced. Then would increase the firm's net income. Okay. Then what happens to its agency cost when a firm increases its financial leverage? The agency cost depends on the debt. Yeah, depends on the interest cost of the debt. If the firm borrows more money, then the firm is responsible, is accountable to pay its interest as well as principal. Okay, then in this case, that would, in this case, the management does not free money to spend. Then in this case, the agency cost would be limited. Okay, so that is the effect of financial leverage on the agency cost. And then the last one is what happens to its risk when a firm decreases its financial leverage. Of course, when a firm decreases its financial leverage, use less debt, then the firm's risk would be reduced, right? The firm's risk would be reduced. Let's look at two extremes. Yeah, now we have two forms, form A and form B. Form A is financed, totally financed by equity. And the form B is fully financed by debt. Then do you think which form has a higher risk? Of course, form B has a much higher risk, right? So in this case, yeah. In this case, if a firm borrows more money, then that would increase the firm's risk. Okay. Now, after we know this, after we know the capital structure, now let's look at the weighted average cost of capital. WACC, yeah, weighted average cost of capital. In this case, yeah, we have a overall cost of capital for a firm using the cost of each kind of capital that we have computed. Yeah, we know, right? Yeah, the total assets is financed by debt, by equity, by preferred stocks. Okay, now, what is the overall cost of the total assets? Then we introduce with a weighted average cost of capital. Okay, is for the time being, yeah, we ignore the tax, we ignore the effect of the tax, or we suppose there is no tax. Okay, then in this case, yeah, we can use this formula to calculate the overall cost of capital, or WACC. WACC equals the weight of equity times the cost of equity plus the weight of debt times the cost of debt, then plus the weight of preferred stock times the cost of preferred stock. I use a parenthesis here. That means, yeah, if the firm has preferred stocks, yeah, in the real world, some companies do not issue the preferred stocks. If a firm does not preferred stocks, then we don't have this. We don't have this term. Okay. So this overall cost of capital, yeah, is the required return on the firm's total assets. Okay, yeah, if that means the overall cost of capital on the firm's total assets. And it is based on the market's perception of the risk of the firm's future cash flows. In the previous slides, yeah, we ignore the effect of tax. However, in the real world, yeah, a firm does have to pay the tax, right? So now, yeah, we include the effect of tax. When we consider the tax, we are concerned with after-tax cash flows. Okay, so we also need to consider the effect of tax on the variance of cost of capital. Okay, yeah, we have to look at it. We have to consider the effect of tax on the various cost of capital. Okay, of course, yeah, out of three types of cost of capital, tax affect the cost of debt, right? Why? Because interest expense reduces our tax liability. Okay, then this reduction in tax reduces our cost of debt. After we consider the tax effect on the cost of debt, then after-tax cost of debt can be calculated with this equation or with this formula. That is cost of debt before the tax times 1 minus TC. Here, TC is the tax rate. TC is the tax rate. Okay. Suppose you use suppose the RD suppose the cost of debt is 10%. All right, is 10%. And now that is RD. And now you use you borrow $1. Okay, then debt is $1. You borrow $1. Okay, and then you have to pay 10 cents. Right? You have to pay 10 cents as the cost of this $1. Okay. However, because this is the interest expense, right? This is interest expense. That means if you borrow $1, if cost of debt is 10%, then you have to pay 10 cents as cost of debt. However, for this 10 cents, suppose your TC, your tax rate is 40%. Is 40%. Okay, then for each cent, the the tax deductible. Okay, for for each cent, 40% is tax deductible. Okay, because it is tax deductible. You can deduct this cost from your income, from your net income. Then for each cent, your actual cost is 60%, right? Is 60%. Okay, then that is that is then that is your then that means your tax your after tax cost of debt is the is 10% times 1 minus tax rate. Tax rate is 40%, right? Is 40%. Then in this case, that is 10% before tax cost of debt, then times 0.6, then that is 0.6%. Sorry, that is 6%, not 0.6. Okay, 10% times 0.6, then that is 6%. Okay, after considering the tax effect, then your after tax cost of debt is 6%. Okay. Then you may ask, what about dividends? Because dividends are not tax deductible, so there is no tax impact on the cost of equity. Now, after we understand this, we can rewrite the WACC as the weight of equity times the cost of equity, then plus the weight of debt times the before tax cost of debt times 1 minus tax rate. If we have, if the firm uses preferred stock, then we include this term. That is the weight of preferred stock times the cost of preferred stock. Okay. So finally, we have WACC. We have a formula to calculate the WACC. Now let's look at an example. Let's have a form. We have we know the information. We know this information on the slide about the form. First of all, we know its tax rate is 40%, and also we know its total assets is composed of three components. The first one is debt. And the second kind of asset is preferred stock. Then the third one is common equity. And this column shows the weights of these three kinds of assets. Okay, and this column shows the cost of these three kinds of assets. Of course, we have estimated the costs of these three kinds of assets. For the debt, the cost of debt before tax is 10%. The cost for preferred stock is 9%, and the cost for common equity is 14%. Now you can see, right? The common equity is the highest risk asset, so it has the highest cost of capital, and then the debt has the smallest risk. In this case, okay, this example doesn't make much sense. Okay, I think according to this, anyway, let's suppose that this is an individual form. Okay, generally speaking, the debt should have debt has the smallest risk. Then the cost of debt should be smallest, and the risk of preferred stock is in between, and then the cost of preferred stock should be in between. Okay. Anyway, so for this example, for some reason, preferred stock has a smallest risk. That is possible. Okay, that is possible. And then, yeah, we can calculate. We can use the formula. We can use the formula to calculate the WSEC, the weighted average of cost of debt of capital. Yeah, the weighted average cost of capital. Then we plug in the number into the formula, and then we can get 11.1%. Okay, so that is an example how to calculate WSEC. Now let's look at what factors would affect a company's WSEC. Of course, the market conditions, especially the interest rate. We know, right? Interest rate is determined by the market, and also the market risk premium. It is determined by the market. Okay, and the second one is the firm's capital structure. Okay, the weights of three kinds of assets in the firm. Okay, and then also the other one is tax rate. Is tax rate. Okay, and finally, that is the firm's investment policy. Okay, if firms have riskier projects, then generally this firm has a higher WSEC, higher weighted average cost of capital. Now let's look at the example. Let's look at the other example. Okay, we have equity information. Now this company has 50 million shares, common shares, I think. The price per share is $80. And also we have estimated the beta systematic risk of this firm, that is 1.15. And also we know the market risk premium, right? What is the market risk premium? That is expected return on the market portfolio minus risk-free rate, right? Then that is on the market. On the market, risk premium is 9%. Okay, and then we know risk-free rate is 5%. Risk-free rate is 5%. In this case, then we would know, market expected return would be 9% plus 5%. The expected return on market portfolio would be 14%. Would be 14%. Okay. Now, also we have debt. This firm has incurs debt. We have debt information. We know 1 billion in outstanding debt. Face value is 1 billion. Okay, and the current quote is 110. So that is a quoted price of its debt, right? Of its debt. If one bond, now let's suppose, it is bond. The debt, all debts are bonds. Then if the face value is $1,000, then market price would be $1,100. Right, that is the market price. Okay, market price. Okay, then the coupon rate is 9%. It is semi-annual coupon. Semi-annual coupon payment. Semi-annual coupon bonds. Okay, or coupon payments bonds. It is 15 years to maturity. And also we know tax rate is 40%. This firm has a tax rate 40%. Okay. Now, let's see. What is the weighted average cost of capital? First of all, let's calculate the cost of equity. We use campaign to calculate the cost of equity. Okay, here the required rate of return equals 5%. What is 5%? 5% is a risk-free rate, right? Risk-free rate. It's a risk-free rate. Okay. Then plus 1.15, that is the beta of this company's equity. Then times 9%, that is the market risk premium. Okay. I like to emphasize again. Okay, when we use campaign, we can use a percentage. Then we can get the cost of equity, that is 15.35%. All right. Now let's look at the cost of debt. Cost of debt. Yeah, if we look at the cost of debt here, yeah. In this case, the firm has 1 billion debt in outstanding. Okay, 1 billion debt in outstanding. If that is the face value, Okay, just as we know, okay, the bonds are standardized debt. Okay, are standardized debt. So for each bond, even if we have 1 billion, 1 billion bonds, each bond has the same market interest rate, right? So in this case, we don't have to care about the value. When we calculate the cost of debt, we focus on the interest rate. Okay, we focus on the interest rate. Then in this case, what is the interest rate of the debt before the tax? Okay, now we can calculate, right? We can calculate it. And for each bond, it has the remaining maturity 15 years. Okay, it has 15 years to the maturity. Okay, and it is the semi-annual coupon payment bonds. So in this case, the N, we're going to use a financial calculator to get the interest, the required interest rate. So N is 15 times 2, right? There are 13 half years before the bond before the bonds expired. Okay, and then IRY is what we're looking for, right? Okay, is what we're looking for. Now what is the present value? Present value is now we know. Okay, current quoted price is 110. That means for a bond with the FS value of 1,000, its actual market price is $1,010, $1,100. Okay, we define this as negative, and then what is the payment? Okay, coupon rate is 9%. That means the annual coupon payment is $90. The half year, the semi-annual coupon payment is $45. Because present value is defined as negative, then payment is positive. Okay, then what is FV? FV is $1,000. Okay, it is positive. It is positive. Then you can get the IRY 3.9268. The unit is a percentage, right? The unit is percentage. However, this is the required interest rate per half a year. Okay. Then in this case, yeah, we have to to make the capital cost consistent with each other, we have to convert it into the annual cost of debt. So times this number times that by 2, we get 7.854%. That is the before tax cost of the debt. Okay. Then what is the after tax cost of debt? Of course, yeah, that should be this number. Should be this number times the same number times 1 minus tax rate 0.4. Then we can get the after tax cost of debt, that is 4.71%. Okay. Now after we get the question doesn't mention the preferred stock, so we assume this company does not have preferred stock. Okay. Now we're going to put them together to calculate weighted average of cost of capital. Now, then what are the capital structure ways? Okay. Now we know equity. The market value is 80. 80 is the price per share times 50 million shares outstanding. So the market value of equity is $4 billion. Okay. Now, what is the market value of debt? We know, right? Yeah, the book value of debt is 1 billion, and the market price quoted is 110. Okay. Then in this case, the actual market value of total debt should be the book value 1 billion times 1.1. Then that is 1.1 billion. Okay. And then the value of total, the market value of total assets would be the value of equity times the market value of equity plus the market value of debt. So that is $5.1 billion. Okay, and then this is the cost of equity. We just get this number in the previous slide. This is the this is the weight of equity. Yeah, this is the weight of equity. The market value of weight is 4 billion divided by the total the total market value of assets. Okay, then we get the weight of equity 0.7843. Now we calculate the weight of debt. Okay, the market value of debt is 1.1, then divided by the market value of total assets 5.1, then we get 0.2157. Okay, now what is the WACC? We plug these numbers into our formula. Okay, then we have the weight. This is weight of equity, right? Times the cost of equity. In this case, I use a percentage to express the cost of equity, and then plus the weight of debt times the cost of debt. This is the after-tax cost of debt, right? And then we get 13.06%. Yeah, now we can see the weighted average cost of capital of this firm is 13.06%. Okay, so that is all for this section.